And so here we're being asked to determine whether the given function is a solution to the differential equation. So to be a solution, it has to satisfy the equation when it's plugged in. Now it's a second order equation. We need to find y prime and y double prime first. So what's y prime?
-2 even to the right.
Is it minus x to the e to the negative x?
Plus e to the power of the negative.
It might be simplified. Second term required product program. Second derivative now.
Negative x.
What is it?
E to the negative x.
Keep going.
Minus x e to the negative x.
Got it.
Plus.
Keep going.
So where you plug it in.
Minus.
E to the power of the negative.
And that'll just become x e to the minus x, right? Now, we plug those in. Therefore, y double prime plus 2y prime plus y is going to equal, I'm going to put these in parentheses. 2e to the minus x minus 2x e to the minus x. Those are all like terms, right? They will sum out to 0. That also sums out to 0. Equals 0, which is what we wanted it to be. So that is a solution. Show that 1 over x squared minus 1 is a solution of y prime plus 2xy squared equals 0 on the open interval minus 1 to 1, but not on any larger interval containing I. Now, first thing to do is let's just show that it actually is a solution. And notice the wording. This one was asking to determine if it was. This one's saying to show that it is. That is a solution. You have to show it. We only need to go up to the first derivative here, right? What is its derivative? How would you go about finding the derivative?
Negative 2 over x squared minus 1 squared.
You said it was negative 2.
Over x squared minus 1 squared. So,
How'd you get it?
by putting parentheses over x squared minus 1 and then raising that to the negative 1. And then taking the integral, the derivative of the inside is 2x. And then, so you bring the 2 out. So it's negative 2 times x squared minus 1 to the negative 1. And then you add, or then you subtract from the exponent. Does that make sense?
What did you say the derivative of the inside was?
2x.
Where's the x?
What do you mean? What?
You just said the derivative was 2x, right?
Yeah.
What happened to the x?
So is it 2x, negative 2x on top?
There's your derivative.
Okay.
That's the easiest way to do it, is to use the chain rule. If you're a masochist, you could also use quotient rule. Y prime plus 2xy squared. Well, we have y prime. Just put parentheses to indicate you're substituting. We get 0. That's nice. So we have that it is a solution. What's the domain for the solution?
All real numbers except 1.
So it would be a solution on the open interval negative 1 to 1. It's defined there. But if you now make that interval larger and still contain negative 1 to 1, it would no longer be a solution. Because you can't have negative 1 and positive 1. Right, since it's undefined at plus minus 1, it cannot be a solution on any interval that would contain negative 1 to 1. Again, the interval that it's a solution on is generally fairly straightforward. It's generally implied. You're not going to have to worry about finding it. So those are the general basics of differential equations. Make your definitions. Any questions?
Can you go back on the previous slide? So to get y prime, you did the quotient rule?
I did.
What was these?
I didn't find the derivative at all.
So how do we get to the answer?
Yes, sir.
How'd you get it?
Chain rule, I think?
Chain rule?
Mhm.
Not the same as that. That's the general power rule.
Right.
Negative 1 times the function raised to the minus 2, then times the derivative of the function. And the derivative of x squared minus 1 is 2x, right?
Yeah.
So negative 2x over x squared minus 1 all squared. You could use quotient rules well. They would work. Just not really necessary.
For the domain, why did you include negative 1 and 1?
They're not included on it.
And why did you include like 5 cells?
Where's one?
You,
Right here.
yeah.
These are unions. This is interval notation for the domain. So it'd be this open interval, this open interval,
Oh, and
or this open interval. So this is saying everything except minus 1, positive 1, because it's open. That's just the interval notation.
What are the upside down 3 dots?
Since or because. Anything else?
What is this topic on?
This is just definitions. And so the entire thing that we're going to be doing, what we'll continue after we do the worksheet break, is combined with this is all just chapter 1 from the textbook. Just an introduction.
That chapter be called ordinary.
I don't actually know what the chapter name is. I just know it's chapter 1. Just going over the prerequisites, definitions, some basic theorems, direction fields. Not actually solving them yet. That starts in chapter 2. Yeah, I think chapter 1 is 3 sections. 1.1, which is just an introduction. 1.2, which goes over the definitions and examples. And then 1.3 is on direction fields. Okay, get into your groups. You're gonna have more time than the 30 minutes that's listed here. Okay, so let's continue. We've now seen how to verify it's a general solution of a differential equation. Let's now see, given the general solution, so let's say we've already found the general solution, find the particular solution to the given initial values. In this case, we're dealing with the initial value problem. IVP will stand for initial value problem. Y prime plus y equals 0. With the initial condition, y of 3 equals 2. And we're told that C1 e to the negative x is a general solution. We don't need to verify it. You can if you want to. Now we're going to need y prime of x as well. All right. So what is y prime? We're still in, I believe, 22. Oh, actually, I'm sorry, we don't need y prime. Just we only have the one initial condition. Y of 3 would be C1 e to the negative 3, right? And that has to equal 2 by the initial condition. Solve for C1. So let's test our algebra knowledge. Pop quiz. How's that simplify?
Two e to 3 minus x.
Here's our solution. The initial value problem, y double prime plus 4y equals 0. Y of 0 is 0. Y prime of 0 is 1. And C1 sine of 2x plus C2 cosine of 2x is a general solution. Now here we are going to need y prime, right? What's y prime?
C1 cosine 2x.
What was it?
C1 cosine 2x minus
What did you forget?
2.
You forgot the chain rule.
Sorry. Minus 2C2 cosine 2x. Or sine of 2x. Sorry.
There's y prime. We have to have that equal to 0, and that equal to 1 simultaneously. Oh, thankfully, this one is nice. What's sine of 0? What's cosine of 0? By the way, you get C2 has to be 0. And the second one says 2C1 has to equal 1. Which means that C1 is half. So our solution is sine of 2x all over 2. Same equation, different initial values. Which means I get to cheat. Y of pi over 8 would be what? C1 sine of pi over 4 plus C2 cosine pi over 4. That has to be 0. We also have to have y prime of pi over 6. We get cosine of pi over 3, right? And then sine of pi over 3. That has to equal 1. And they both have to be true simultaneously. This one isn't really that difficult. Cosine and sine are equal at pi over 4. That would mean that C1 and C2 just have to be opposites of each other. So C1 has to be negative C2. So you can then just replace C2 with negative C1 in the second equation and solve. Do I want to do that? Yeah, why not? We'll do it by hand. What is cosine of pi over 3? What is it?
What's that?
It's half. What's sine of pi over 3?
Root 3 over 2.
That should be C1. And then that becomes a plus. I see. Cause I mistyped that. That's okay, I'll redo this one. That actually wasn't supposed to be a Y prime. We'll do it this way and then I'll go back and do it the other way.
When you go and Y on the let's do pi over 8, what happens to the 2? You get C1 sine pi over 4 plus C2 cosine pi over 4 equals 0.
What's 2 times pi over 8?
2 times pi over 8.
Pi over 4. That's what happened. This should give us what C1 is 1 over root 3 plus 1. C2 would have to be the opposite of that. Sine of 2x over root 3 plus 1. Minus cosine 2x over 3 plus 1. Would be our solution. Okay, now let's actually do the problem that was intended to be. Yes. And this is more of a boundary value problem than an initial value problem. Here we only need y prime. We're still going to have the same result there. C1 has to be negative C2. That's root 3 over 2. Right, sine, we said pi over 3 was root 3 over 2, cosine is 1/2. Solve for C1. Over 3 minus 1. And obviously C2 is then the opposite of that. That would then be the solution, right? Same thing here. I did. Uh, That's also not supposed to be a y prime, but let's do both of them.
Can you go back 2 slides real quick?
Oh, remember, these are uploaded as well. It is again the same differential equation, same general solution. Which allows me to just cheat and do that. Y of 0 has to be 1, y prime pi over 2 has to be 2. And 2 times pi over 2 is pi. Sine of 0 is 0, right? That says that C2 has to be 1. Cosine of 0 is 1. What is cosine of pi?
Negative.
And what's sine of pi?
Here.
That gives C1 is negative 1. Then we get y of x is cosine of 2x minus sine of 2x. And that was not supposed to be a y prime. Fix that. This is another boundary value problem. Doing this, we're told C2 is 1 and negative C2 is 2. What's wrong? What's wrong with that?
C2 cube with
That's saying that 1 equals -2. Huh. That's definitely not the case. Why don't you go away? Thank you. That is what we call a contradiction. That means there's no solution. That IVP has no solution. Oh, actually, that's a boundary value problem. It's an EVP.
Would you be able to see that right away just from the problem, how it's asking you that, or do you have to write it out, I guess, to see that?
I would run an explanation.
Okay.
Because it doesn't necessarily have to be the case that you get no solution. In this case, it is. So you'd have to explain yourself. Now, this one is correct. Determine C1 and C2 so that this solution, so that this function satisfies the given initial conditions. Well, y prime of x. What's y prime?
2c1 cosine 2x. Or minus 2c2 sine 2x.
Yeah, same as what we've been working with. Because that derivative of 1 just goes away. That has to equal 0, right? Y pi over 8 has to be 0. Y prime pi over 8. That's easy too.
Wouldn't it be the 1 and y?
Oh, there should be a 1 there, yeah. Now this one is not so simple to solve because that plus 1 there. That's a bummer. Sine pi over 4 is root 2 over 2. Cosine pi over 4 is also root 2 over 2. So you could try to do this 2 ways. Could use the method of elimination, which is taught in algebra. You eliminate as many of the variables as possible and then use back substitution. If you had linear algebra, you could use Gauss-Jordan reduction. It's the easiest one to use, or Gaussian elimination. That's going to pose an issue because we're dealing with root 2 over 2s. Still doable, though. It's going to be hideous. There was a third option. Use a calculator. Guess which option I'm gonna use? Option 3. I'm gonna show you how to do this on a calculator. I'll actually show you both calculator and using Wolfram. Here we go. First look at Wolfram. You two are going to grow to love Wolfram
Why are you?
from Cal 3.
I've used
I'm surprised.
my Calc 2 professors are showing so
The engineering department doesn't like Wolfram. They make you use MATLAB.
I'm even gonna start.
Oh, no, you don't have to worry about it. I hate MATLAB. I've used it. It's awful. One of the worst programs ever.
And to think that it's the lesser of all the evils for I guess engineering software is out there.
What I'm going to do first, I'm just going to simplify it. I'm going to go ahead and define my function. So y of x is defined to be, I'm of course using a keyboard, so it's easy for me to type it in, but this acts as your keyboard. C1, what was it, sine of 2x. I'm not going to type it in for this one. I'm going to show you. If you hit this button here, trig, it just brings up all the trig and inverse trig functions. And you just click sine. Oh, right, okay. Yeah. So what do you notice? The sine is italicized, right? I did a multiplication there, so it doesn't read it as one continuous string. Plus C2 times cosine 2x. No, just copy the whole thing. Okay, why don't you do it anyway? I am going to define a new function. I'm going to call it y1 represent the derivative. Oh, right, with respect to x. And again, type out derivative y of x with respect to x, or menu, calculus, derivative. Excellent. Solve. And again, menu, this one is under algebra. Solve. So let's see if I remember how to do this, because it is a system. I can do solve systems, but I know there's a way I can also do it with just the solve command. y of, it was what, pi over 8? So you're gonna just type out pi, or right here. We said that had to equal 0. And that had to equal square root of 2, right? Then you just need to tell it what are we solving for. C1 and C2.
Is 2. C, y1 equals to 2.
Should be square root of 2, right? It's root 2. There's your solution. Yes, you could also use the system. I don't like the calculator though. So come over to Wolfram, and I did create a free account. I'm not going to use my own account for legal reasons. I'm sure I'm allowed to. So I'm going to create a new notebook. And then we're good to go. However, I'm going to do one additional thing. Then under view. Just for your benefit, I'm going to increase the magnification. Let me show you what 100% looks like. It's default. Very tiny. Bless you. Even that's kind of small. Bless you. Thank you. I'll go up to 300%. Notice that I'm using a capital S. Right now the string is blue, that means it is reading it as a string. When the text is black, it's reading it as a command or a built-in function. And it's always brackets. Now, what are we solving? Actually, let me first define my functions. Y of x, underscore tells it that it's an independent variable. So again, notice that that text turned green. This represents an independent variable. C1 times sine of 2x plus C2 times cosine of 2x plus 1. Yeah, I'm going to do it this way. Now I solve. Y at pi over 8 equals 0. I use the double equals here. I think it's a double ampersand. The derivative y of x with respect to x. So that one, or is it this one? It's this one. This is saying it's the derivative, now evaluated when x is pi over 8. I may have to change that, that may be the wrong order. I'll find out soon if it gives me an error. And that has to equal square root of 2. Now I need to solve for it. I have to put it into braces. I want to solve for C1 and C2. This is why I don't have to actually put in another line for the derivative. Uh-oh. I did not like that one. I did not like that. Two times. I'm gonna have to do this. Maybe it is this direction. No. Okay. Why are you not working? I have it the right direction.
You
Maybe I can't do that. Maybe I'm gonna have to do this. That's odd. I was allowed to do that. I have to do this. Yeah, that would work. Okay. That's how I have to do it. So apparently I can't use the evaluate add within the solve command, which is annoying. But, you know, that's what it is. You also saw I did y prime of pi over 8, which is the same thing. Take this derivative back to pi over 8. But we get the same solution. Just two different ways of doing it. And again, this is the way that I prefer to do it, using Wolfram. So what I'll do is I'll do this. Copy. You won't let me paste it as a photo. Where's you want? I can do this. Copy image. Thank you. I'll just paste the solution in. What you would have to do for the group assignment is also include the input. And you just copy and paste both the input and the output and insert it in. But we'll talk about that next week. This gives us as our solution Oh, actually, I don't think I have to, right? They just said define C1 and C2. So I don't need this. There they are. Right, or any equivalent form. Which brings up an interesting case. You would always be able to use a calculator to solve a system like that, unless the problem specifically told you not allowed to. Like if I wanted to see if you could do it by hand. The only thing you won't be allowed to do is use the differential equation solver, which I believe the T-Inspire CX2 does have. You just can't use it for this course. But just about everything else is fair game. You can also use it to take integrals and integrals if you want. Again, unless you're specifically built on. Determine C1 and C2 so that y of x satisfies your initial conditions. Y of 0 equals 0, y prime of 0 equals 1. That's right, y prime. What is y prime?
Two C1 e to the 2x plus C2 e to the x.
And then we have to have y of 0 equals 0 and y prime of 0 equals 1. What's e to the 0? And this is, again, a fairly straightforward system to solve. C1 has to be negative C2. C1 has to be 1, which immediately means that C2 has to be negative 1. And we'll do it. And again, as we'll see when we start solving differential equations, the first step in solving initial value problem is to find the general solution. And then it's just this, to find your coefficients. Questions so far? So I hope you're good with your algebra and your arithmetic. Now, what I will show you is I probably will be posting the Wolfram files. However, you won't be able to open them unless you have a specific app. You just want the Wolfram Player, which is a free app. It lets you view, but that's all it's going to let you do. It won't let you execute anything. And so it's just there to let you view the notebook files, which is what Wolfram file is. It's a notebook.md. So you just download the Wolfram Player and it'll let you open up those files. Again, you can't do anything with them. But it would let you view it on the desktop. Or you might even be able to just download it and upload it into your cloud, which would then let you open it up on here, which would then let you do the executables. I'm actually not sure how that would work. Maybe My Files, upload, yeah. So you could also do that. Just download it, then go to the Wolfram Cloud, My Files, upload. And then just click the file and it'll open it. So either one. And we will be using Wolfram a lot. So specifically, next week, when we look at direction fields, that's exclusively Wolfram to construct the direction field. Speaking of next week, we do not meet on Tuesday. Long week, so 5-day weekend. Which is always nice. Unless you happen to have Friday classes, in which case I'm sorry. You wouldn't even want to teach them. I didn't do this last time, which is Monday, but I generally do try to end with a slide that shows the assignments. That was only one. This is just a reminder that the homework journal will be collected for the first time on June 24th. There's only one assignment up. Right, so there's 3 questions from chapter 1. I think it's specifically section 1.2. I'm not doing anything from direction fields, so I'm not going to make you print them out and paste them in the textbook. But look through the 1.3 exercise when we do direction fields. At least try to plot the direction fields on the end, just so you get used to it. Because for the assignment, I believe you're going to have to do the assignment. And you have to put that into your final turn document. Yeah, and that will be discussed next week, so I can plan on posting the first group assignment. Won't be due week 2, but it'll just be up there. Have a wonderful holiday. I'll see you again on Thursday. Maybe I'll extend it to 60 weeks.
There you go.
Oh.